Yeah, Jason is doing awesome stuff. He's like on the leading edge because VR. A lot of people talk about VR for the like doing games and things like that. And Jason's also interested in exploring VR as a method for kind of browsing data in the web and kind of something that's really revolutionary. So he made this all himself. He put it all together with the other people who were he brought a good team together to do the audio, people to sing. It's very original. So he kind of produced this entire thing. And Jason's going to talk about how he built it from scratch. And Dolby's very happy to have Jason helping us out. So thank you very much. Everybody give Jason a warm welcome.
And push this over here so I have a little bit of room. Okay. So let me get to my presentation. Assuming it will all work. Great. Okay, so by the way, my company, which I'm trying to start, is called Flow, and it's really about virtual reality. This was a fabulous project, which is not specifically about virtual reality, but it uses a lot of the same kinds of techniques you'd want to. So what I'm going to do is I'm going to talk through, actually show you the code, and point you to my blog, which has a pretty deep analysis of the code that I did. So I'm going to talk to you about how to produce audio for Dolby Digital Plus, so a 5.1 surround. That's pretty quick. Then talk about the web audio context. How do you create audio that can be spatialized just in your browser, and show you the code to do that. Pretty straightforward stuff. And then the WebGL part of it. So what I'm doing is I'm doing a bunch of textures that are dynamically taking the amplitude out of each of these tracks and manipulating the shader language to make them all glow and ripple and do the stuff that they're doing. So that's the combination. That's what I want to lay out on for you guys. So Dolby Digital Plus, as Titus said, is a new codec. Even if you're not using the 5.1 aspects of it, it's about half the size of MP3 files and sounds way better. So that's kind of cool. Right now it's built into the Microsoft Edge browser and in the latest Safari. This project only works in Edge, at least only works in Edge for the full surround sound. I'll also show you a little bit of code to fall back to use MP3 files if the surround sound codec isn't available. And so that's pretty straightforward. And so let's see, technologies, I actually just told you all that. Okay, I'm using the Web Audio API, which is built into all the major browsers, ThreeJS on top of WebGL, and I already talked about Dolby Digital Plus. I used GLAM for this project to help me with some of the interactivity. It's something by Tony Parisi. It's called Graphics Libraries and Markup. It's not going to be really much about this talk, and it's only kind of a small part of the project, but it just made things a little bit quicker for me. One of the things that I think is kind of interesting to think about this project is that I really didn't know what I was doing when I started. I have a master's in music, so I know how to produce music, but I had never done any shader language before. Obviously, I've done some pretty sophisticated ThreeJS stuff, but otherwise, I had to learn a whole bunch of things. And so where did I learn it? Of course, from the web. So one of the things one of my inspirations was a friend of mine, Isaac Cohen. If you haven't checked this guy out, you should check it out. It's amazing, amazing stuff. And let me turn on my hotspot, and maybe I can actually get to it. And if this doesn't go very quickly, then I will bail. But okay, my internet connection is too slow to do those demos, so we are going to just bail on that process. But Shader Toy is a great place to learn and experiment with WebGL, with shader language, and then you can grab that and plug it into WebGL really straightforwardly. And anything that I can't get to in an obvious way here, you can go to my blog. I've got 4 blog entries that talk through exactly the code that I used for each of the things I'm going to talk about, and also where the shader language came from. So let me get back to the production here, because this is what we really want to do. Okay, so let me talk about just something I did differently in my sequencer than you're used to seeing in typical sequencers. So for my sequencer, I had each vertical column be a 4-bar phrase. If I go back here, each one of those is a 4-bar phrase, and each one of my sounds is not a loop. It's a predetermined length. And one of the things where I thought that was important is if you give somebody, pretty much anybody, a looping kind of tool that's really easy with a whole bunch of tracks, it's really easy to turn on a whole bunch of tracks all at once, and then it's just full blast all the time, and that's not very musical. So by doing it this way, each one of these phrases is actually going to stop and require the user to go ahead and start that other phrase, and that gives you a little bit more musical space in the project. So essentially what I've done here is I've taken 16 audio clips. Each one is encoded with a 5.1 surround sound. One sentence is encoded with a 5.1 surround sound. The web audio context is going to mix those simultaneously to 8 tracks. Using Dolby Digital Plus codec, it will then respatialize those 8 5.1 channels back into a single 5.1 mix. And if you're on headphones, it'll use head-related transfer functions, so you still hear it spatially around you the whole time. Unfortunately, you're not going to hear any of the spatialization because of this particular system today. So you'll have to go to the site, and well, I'll give you the URL. Go to the site and put in some headphones, and then you can actually hear the spatialized part of it. And all of that is done by the web audio context in the browser, and I didn't have to do any plugins. Yeah, question?
Would it be possible to turn the lights on?
More, especially the room lights, right? Because it's okay video-wise. Great. Yeah. So any quick questions on the basic fundamental thing here with getting 8 simultaneous 5.1s mixed? Want to see how to do it? It's a lot easier in the code than you might think. Let's go back to, so bopping around with too many. Okay, so I did hire some real vocalists to do the vocal tracks, and they did some of the parts I wrote and some of the parts they improvised. Once I had the vocal parts, I used Ableton Live, and I grabbed a whole bunch of little clips. I just named them things that could keep me straight on what they were, and simultaneously mixed them into phrases. So, for example, there's one, it's called Vocal Melody. In a way, that's a whole little piece in its own. There turns out that there's 4 parts. I took her voice, and I added a counterpoint to it. Another vocalist improvised a harmony to that, and then I actually added a MIDI track to the same thing so that it would, they'll synthesize the track to give it a little bit more fullness and give it a little bit more interest. So each one of these tracks, each one of these clips is kind of like a set of musical steps in itself. And then how do you spatialize them? So in Adobe Audition, sorry, there's a lot of pieces to this, so I'm going to keep bopping around between applications. Oops. And that's a pain to bop around. In Adobe Audition, there's a track panner. So you start out saying, hey, I want to do a 6-channel or 5.1 channel audio file. And inside the, does it have enough internet to validate? And if it doesn't launch, I'll just do this. In that panner, you can actually drag your mix around. Now, one of the things that's a little bit confusing to understand here is what Dolby is doing is it's taking an existing 5.1 mix and respatializing it based on whatever hardware you've got available. It's not doing a dynamic, take this sound and put it over there, or take this sound and put it over there, right? So that is a little bit of a limitation, and I'm sure they're working on that, especially for like VR applications where you turn your head, right? Because if you're turning your head, you need the sound to stay spatialized over there. So that's not what Dolby Digital Plus is doing. Instead, I'm pre-encoding the surround sound into each file. and then I run it through the Web Audio API, which I'm going to show you quickly. Okay. Oh, just here's an image of Adobe Audition. So here's the track panner, and each, in this case, like the pan angle, I actually created spline curves to map exactly where these things are going to move through space. That was really helpful later on when I wanted to tell the program to put each sound in each space, or to put each visual to match whatever was in the audio file. It's a little weird. I have the audio file first, so that's spatialized, and then I created a visual that stays synced to its animation as it spins around. And I'm just going to use my blog as examples, code examples, because that's quicker than hunting through WebStorm. Okay, so here's the first bit of code. So the Web Audio API, you get to through window.audioContext. And is that big enough for you guys to see reasonably well? We can give it a little, goose it a little bit here. There we go. And basically, every modern browser has the Web Audio context in it, especially browsers on all your phones and everything. I mean, I guess if you go far enough back in IE, you'd have an issue. But so that's the first, is audio supported. And then we're just going to say, hey, can we play this codec? And is it going to let me scroll over to get to the EC3 codec? That's the Dolby Digital Plus codec. And if we can play it, it's going to return either a maybe or a probably, depending on the browser. I'm not sure why that is. When it actually says, yes, I can play it anyhow. And if it returns an empty string, then we know that it's not supported. If it's not, so assuming that it's supported, then we can say, hey, how many channels do you support at this time? And the max channel count is the key little piece. You have to tell it to use 6 channels for a 5.1 mix. That one line of code actually was a nightmare to figure out. But you all know what it is now, and so that will work. And if you're not using EC3, then I'm going to fall back to using MP3 files, and then I am going to use the Web Audio API to put the sounds in space real time. So when I actually do this for VR, I fall back to that, because at least it's going to put it there. The Web Audio API, it's not brilliant. I mean, it's not the best head-related transfer functions. It's not as wonderfully spatialized as it could be, but it certainly is going to pan it pretty well, and that's enough to make it accomplish what you want. Any questions on just how to get that set up before I go on to? Who is new to the, I should say, who's used the Web Audio API very much? Okay, so 3 or 4. So I'll just show you a little bit more of that, which is here I'm going to basically, you just create a buffer source. This is the buffer. The buffer is the actual, the data for that audio clip. And if you're going to use the panner, then you just create a thing called a panner, create panner, and you hook it up, connect it through a chain, and that's going to alter the audio as it goes. So how am I time-wise? Because I want to play a little bit more. Okay, good. So I actually created a little class map for you so you can see what the pieces are. So we've got 16 audio clips. I've got 8 audio tracks. I'm going to map those 16 clips to 8 simultaneous tracks. I've got an audio visualizer, which is connected to an audio track, and that has a shader, the information about how to animate it, and tell it to play and start and stop, along with the sequencer, which tells the whole sequencer, has a list of measures, each measure saying, hey, start now, stop now, etc. So, and the shader, we will talk about the visuals next. Let me just pull this back up again so you can kind of see when I'm talking about 16 clips, I didn't want sometimes I didn't want two of those clips to be playing simultaneously. I didn't want two different bass tracks to play simultaneously because it just turned into mud. So actually you're picking between them. When you click on one of them, see it turned off the other side? So it's going to make those mutually exclusive. The same is true for some of the rhythm tracks, and actually all the tracks. Okay, back to the visuals. Oh, sequencer. If you want to know more information about the sequencer, you can check out my blog. And do we have enough internet? Good. Okay, so the animation was actually one of the hardest parts of the project, mostly because I had to do a lot of math, and I'm not a math genius. So, I mean, I have a music degree, right? And that was 30 years ago. But one of the things I did specifically, so basically I created an animation where I say, hey, here's how long to make it, using a series of keyframes, and I actually put my keyframes as in terms of which beat, or actually that's which measure should this visual be at what time. So in this case, at bar number 1, I want it to be at 56 degrees. At bar number 2.75, I want it to be at 37 degrees. And the rest little animation tool will map that around. The reason why I used these numbers instead of all the other ways you could describe points in space or animations is because it's what Adobe Audition generated. So when I dragged this thing to here, it said, oh, it's minus 75. Okay, that's the numbers I want to use because there's a lot of data points for all the different tracks, like hundreds. And I just wanted to type whatever Adobe Audition told me was type those in without having to do math on each time I typed it. So as a good lazy programmer, I wanted to make it easy. So it does a little bit of the math to map it into the right spaces. And Audition was even, 0 degrees in web audio is different than 0 degrees in Audition, right? So I had to just add the degrees around to make it work. Okay, textures. So once I show you these textures, you'll recognize the imagery a little bit. So these are the actual textures or images I used for my shaders. That's a picture of Lake Tahoe I took. You can see some of the others. Actually, sunset on the water. Bring them into Photoshop and make sure that they wrap so you don't see any edges. And when I show you the project again, you'll see how they actually look. So I'm just going to turn it on again. Hit play. Now that I've told you that that's a picture of some water, you can see it, but you would not have thought of that beforehand because of all the math I do on top of that. So, and it actually is pretty cool. I am going to try to do this, get to my source shader toy again, just because if it works, it is pretty cool. Oh, good. Okay, so I hunted around Shader Toy looking for things that I thought would be relevant to the project. And I came up with this, and I found this thing called Ether. And it just met all the different requirements I wanted to have. I wanted something that's going to glow, that's something dynamic, that's based on time. Okay, I guess it's not going to be happy. Well, I'll just leave it up because you can see the code here. And just started to experiment with all the variables. I took all the variable names and changed them into things that I thought would make sense instead of just being random numbers, and tried to figure out the math. I don't totally understand the math, but let's see if I can get back. No. Let's get back to my... Now I am asking my computer to do an awful lot. It's a Surface Book. It's not a big beefy computer, although it does run pretty well. By the way, as long as we're here, the blog I'm showing you is at flow.gl/blog. I want to walk through that shader language and how to get it to work in the browser. And how are we time-wise? So 11:20. Okay. Does anybody know how long this was scheduled for? 12? Okay, good. I don't want to do the wrong thing. Okay, so to do the textures, before I show you the shader language, let's show you the ThreeJS code. So if you haven't seen ThreeJS code before, then yeah. ThreeJS is this library which seems to be the standard at this point for doing WebGL. You can do WebGL directly without using the library, but there's so many, it just takes so many lines of code to accomplish actually very simple things that pretty much everybody I know is using ThreeJS instead. And there are other options out there, but hey, I'm going to promote ThreeJS because it works great. So in this case, what I'm going to do is I'm going to create a plane, and I'm going to load this texture, which I already showed you. And if I could scroll, that would be nice. There we go. You tell it, you're going to give it two important little bits of code that are actually going to be run on your GL chip. And that's your fragment shader and your vertex shader. Your vertex shader is, so shader language is a simplified form of C, and it's designed to run very, very fast in a multiprocessor environment. So on a big gaming device, you know better than I do, Brandon, but a big gaming box is going to have something like 2,000 simultaneous processes, something like that. I think on my computer it's more like 256. But you still got this little supercomputer that's running very, very, very fast, very simple code, and figuring out what to do with a whole bunch of points in space simultaneously and a whole bunch of colors and pixels in space simultaneously. And so you've got two different bits of that. Like I say, one of it is vertex shader, which is tell me how can I manipulate the points in space, and the other is the fragment shader. How can I manipulate the color of those points in space? Is that an oversimplified definition?
Close enough.
Brandon Jones is from Google, and he's like the god of WebGL and virtual reality at Google. So I'm embarrassed to be standing in front of him instead of he himself. So we're going to create a plane, and we're going to map these two little bits of language of shader language. So first, okay, I don't even bother to show you on my blog the vertex shader because it's doing nothing. I'm not doing anything with moving points in space on the GL chip, but I'm doing a lot with changing the colors. So a bunch of this code, maybe this chunk here, no, at least this chunk here, was from ShaderToy. I went through and manipulated all of the little bits, and I added the main input which I wanted to add, which is I'm actually going to pull in the amplitude of each track and have it ripple my texture that I loaded. So the texture gets loaded here in the UV. VUVs is the actual, wait a minute. Yeah, base texture, hold on. Scrolling this thing is driving me crazy. But anyway, so you're gonna, onto the chip, you're gonna load a texture, and then I'm gonna do a bunch of math on top of it, and what it's gonna spit out when the time it's done is a color with an alpha, and that's the whole process. And then you need to make sure that you've got an update loop that's gonna tell it to update the amplitude coming out of the Web Audio API for each of those tracks. And then there's some picker stuff, which is where I used GLAM, and I didn't talk about that very much. So after all of that, let me play it again, Sam. so you can kind of see how it works. There's two interfaces to it. There's the sequencer interface, and then you can also click directly on the objects. And I'm sorry it's a little bit light in here. And when you click on them, it takes a moment to start. And the amplitude mapping into the shader. Just imagine that sweeping around you in 3D in audio space. So the next piece of this, just because I could, was since I do virtual reality and web VR, I just took it and put it on my phone. It works fine on Android and iOS, and you can drop it into like a cardboard device. I actually drop it into Gear VR with good headphones, and it's particularly fun. I've had gotten a lot of good feedback demonstrating at a number of art shows and technology and art kinds of combinations. So that's the whole story. I'm totally open to questions or ideas or whatever. Yes?
Is it available for like download?
So all of the code is open source. Trying to think if it's not really organized in a good way on GitHub, but if you go to my blog, you can see all the important bits about how to do each of the pieces, and you can of course do view source. It's all unminified except for one little piece around the text engine, which is a kind of a different project I'm working on, and I couldn't open source that. Yes. I'm always there for those because until right now the browsers that do VR are beta. And so the minute they're not beta, I'll be able to get them out there. So there's a Chromium beta that has WebVR built in, and there's Firefox Nightly has WebVR hooks built in. And they work much better than browsers without those hooks. It has to do with how they're pulling the head tracking or the gyroscope and accelerometer data off of the phone. And so when those come out, then I'll be able to release that. But right now, if I put it out, there'd be so many issues with, I don't know, you could even get sick if you don't, with all this stuff flying around you, if you don't have a fast enough update. So I'll get it out there. But right now, this project is live at dolby.flow.gl, and you can go to it and put on the headphones and check it out. Let me turn this down a little more. So the web audio API is going to take 8 6-channel tracks. So each one of them has 6 channels, and it's going to mix them all down to a single 6-channel output. And It just does it for you. And it's been built into the API for, I think, a long time, whether people have been able to use it very much or not.
I'm also curious, do you put a compressor on the master, or how do you handle like the gain staging if you have 16 tracks and you don't know how many you're going to be playing at once? How do you handle like gain staging?
The Web Audio API does it for you. If you wanted to have total control over it, that would be a challenge. That's not great, but it actually seems to be really intelligent and do it pretty well. Okay, yeah. So I actually didn't do all of my mixing in terms of volume. I pre-mixed into the tracks themselves, and the reason for that is the rest of the audio mixing I'm going to do is I'm going to change the volume of the sound. Certainly with if it's a 2-channel, if it's doing the MP3s instead of the Dolby Digital Plus, I'm going to change the volume based on how far it is from you, right? So I actually dynamically did that. And I figured if I'm doing that simultaneously with trying to maintain another mix, I would drive myself crazy, and it was only a 2-month project. So, but I can see that if you're really careful about exactly how each of the relative volume of each of these tracks, it could be kind of a pain. Yes? Oh, right. So where do you get the tracks to do this? Yeah, that's a challenge. Like I say, I have a master's in music, so I just composed them out and made them. And there's enough budget in the project to hire a vocalist to do the vocal parts. One of the things I've thought about doing, especially for VR, is to provide this as a tool set that then musicians could write tracks and visual artists could do the audio parts, and even dancers or motion artists could dance the animations into space, right? And put together a whole system that you could do production after production. But I haven't done that yet. I'm kind of distracted with some other VR things right now. But yeah, that would be fun. Anything else?
You're saying that you showed some VR. Do you have any like control system for when you're showing on
So in VR, I only give you this interface. Basically, it's a gaze and tap. So when you look at one of these objects and then you tap on the side, it will start it basically the same way I just did there. Sometimes there's a little delay before your 4-bar phrase comes around, but so it's only a gaze and tap on VR right now, right? I'll take the whole sequencer and put it in VR too. You can just put it on a canvas and put it onto a plane and then gaze over parts, but I just haven't, until I'm ready to do VR as a real release, I haven't taken the time to do that. I think that's probably, we should call it there. Yes, thank you.